And today I'll be sharing a few ideas on the pediatric mTBI diagnostic approach. So the thing is, this topic is very much closer to the hearts and minds of emergency medicine physicians, essentially because the diagnosis relies on CT scanning as a first-line approach, where radiation exposure to the children is involved after the sedation, and CT scanning many times turns out to be absolutely normal despite having mild traumatic brain injury. So, considering these disadvantages, conventional mTBI algorithm that emergency medicine physicians used to follow, it used to avoid CT scanning as much as possible. So, the thing is, there is a scope for adding neurotrauma biomarkers on point of care basis in this very conventional algorithm. So, what are these neurotrauma biomarkers? Well, there are two: GFAP and UCH-L1. When used together, they have negative predictive value of 99.3%. So if they turn out to be negative, you can definitely say that you have ruled out mild traumatic brain injury. US epidemiological statistics that we have suggest that 600,000 children get CT scanned annually, and this data is from year 2000. Okay, 600,000 children get CT scans annually, and 500 children amongst these cases are estimated to get cancer due to this exposure. Point of care neurotrauma biomarkers have turnaround time of 15 minutes, while avoiding sedation for imaging studies and radiation exposure. And that makes a compelling argument for usage of neurotrauma biomarker as first-line diagnostic modality. So let's go over the conventional mTBI algorithm that we have been using. So if the child has GCS of 14, or if the child has altered mental status, then we were getting the CT scan done, and who would disagree on that? But the caveat used to be that even after doing the CT scanning, many times, even if the GCS is at 14, the child used to turn out to be absolutely normal as per the CT scan. Of course, if the mental status is not deteriorated, even if the GCS is 15, and then of course, even if the child might be having a scalp hematoma, history of LOC for more than 5 seconds, or severe mechanism of injury, still this algorithm expects that the child not be put through CT, rather be kept observing to see whether the child is deteriorating in terms of clinical parameters. So this algorithm, this classic algorithm, also tries to protect the child from radiation and sedation. So there is a scope for fitting neurotrauma biomarker in this algorithm, and that is what we will try to kind of give a thought to. Okay, alright, so let's see over here. The child has GCS of 14 or altered mental status. We will recommend CT. If the child turns out to be positive on CT, then of course it is CT positive mTBI. But if the CT turns out to be inconclusive, in that situation, we will do NTBM testing, that is neurotrauma biomarker testing. If that turns out to be positive, then in that situation, we will consider that as CT occult mTBI. And then, of course, if the child is not having GCS deteriorated, then we will urgently go for NTBM testing only without any CT scanning. Over here, if you remember, when we were keeping the child under observation, now we don't need to keep the child under observation. We can directly go for NTBM testing, and if the NTBM testing is positive, then we will go for MRI brain. MRI brain, of course, in MRI brain also there are various modalities which can be used. With mTBM testing, if GFAP is more than 140, then we can go for regular structural MRI. But if the GFAP is between 20 to 140 picogram per ml, then we need to go for resting state functional MRI or microstructural imaging. So GFAP also gives you precision in choosing what kind of modality that you would want to go for. Of course, if NTBM testing turns out to be negative, then you can immediately discharge the child. Okay. So the thing is, the studies that have been done in 2019 give very interesting perspective on how effective NTBM testing can be. As you can see in this particular table, the CT negative 450 patients were found to have quite a significant rise of GFAP in their plasma. So this modality does hold a promising result when it comes to mild traumatic brain injury. So given this perspective, since CT negative patients turn out to have mild traumatic brain injury and GFAP shows those kinds of outcomes very clearly, we can definitely create a diagnostic classification into CT positive mTBI and CT occult mTBI. Since the conventional mTBI algorithm is for less than 2 years and more than 2 years, these are the two different algorithms that we have. And then, of course, epidemiological studies have shown that the incidence of mTBI in pediatric population is more in children under 4 years. So, considering those things, we have another algorithm for children aging 2 years or more, and that also is very much valuable, making it very clear that basilar fracture is something that you should anticipate, the signs of basilar fracture. Alright, so in this algorithm also, of course, as you can see, the diagnostic classification, okay, has been, I have tried to fit the diagnostic classification over here, and that adds to the value in this particular conventional algorithm. So, to summarize, the key necessities for this novel approach with neurotrauma biomarkers is that sedation becomes absolutely dispensable in children in the imaging studies. Reduced probability of radiation exposure. We don't need to expose children to radiation altogether. Yes, CT is a valuable modality. Yes, it has to be there, it needs to be utilized, but with kind of clarity of thought and not just haphazardly and randomly. Shorter wait time since the point of care testing has turned around. Time of 15 minutes only. Negative predictive value of 99.3 means that there will be absolute clarity of thought as to whether child needs to be monitored, should the child be admitted, or can the child be discharged. Of course, we have a multimodal approach as well coming in with neurotrauma biomarkers, since we can tell with precision as to whether what kind of MRI modality we should be going for. So if we can have that kind of precision, then the argument for neurotrauma biomarkers does make sense and is very much imperative for us to go for this kind of investigation.